In this video, we're going to talk about an array list structure. This is something like an array, but it's in Java, it gives us a little more flexibility. The array list data structure is not covered in the Gaddis book, so I'm going to use uh, this media from the Murach Java programming book, which you guys probably don't have. But just know that you should get everything you need to understand array lists from this video and from the following examples. Also, anything to have to do with array lists in Java is easily found on the internet. So an array list and an array are basically the same structure. They both are, an array list is just like an array. It's got multiple elements of the same type. It's got element 1, 2, 3, etc. And you can put things in it and change values. The key difference between an array and an array list is that arrays are fixed in size. And so once you create an array of 10, that array is always going to be 10. It can never get bigger or smaller. An array list starts empty, and you can add items to the array list. I can do an array list.add, an array list.remove, and I can increase and decrease the size of the list. So you can see immediately the value of that. So if I don't know how many elements I'm going to have, then using an array list makes it very easy for me to increase and decrease the size of my data. So if I'm going to prompt a user for a list of numbers or a list of grades or a list of inventory, something like that, I don't know how much I'm going to get. So creating an array of a fixed size is going to be a little limiting. So I want to use an array list to do that. They essentially work the same way, arrays and array lists. They just have a slightly different syntax on how to use them. So we'll dive into some of that here. So here's an example of an array at the top. You see, you create a new array, var scores equals new integer array of 3. We assign 0, 1, and 2. And then we can use the enhanced for loop to go through that. Here's an array list. Very similar, instead of creating a new integer array, we create an array list of type integer, and we use this kind of angle bracket notation. Also note that we're using the wrapper class, uppercase integer, uppercase double, instead of the primitive data type. So if we want an integer array list, we don't use int, we use the capital I integer wrapper class. And then because the array list, when you create it, it starts as empty. There's nothing in it. It has 0 elements. You then use the add method. So scores.add now adds and adds to the array list at element 0. Scores.add 89 adds at element 1, etc. And so now you have, when you're done with this, you have basically the same data in the array and the array list. And also the enhanced for loop works the same way on an array list as it does an array. Here's the constructors, array list name. So this is the type, and array list of type integer string double. You have the array list name. It equals create a new instance of array list of the type. So very simply, it just looks like this. Array list of string named codes equals new array list of string. Notice that you have to use the parentheses here. So when you create the type of this is array list of string, it looks just like this. But when you actually call it a new, you're calling a constructor method on the wrapper class, and so you have to use the parentheses here. Okay. And you can actually insert, you can initialize the array list to empty elements. This is really rare to see that done, but it does do that. An array list is slower in execution time than an array because it is, there's logic to make it bigger and smaller as it works. So it is a little slower, but if you're dealing with thousands or even hundreds of thousands of elements, you're not going to notice. Particularly in this class, you're not going to be able to tell that an array list is slower than an array. But just know that if you're dealing with really large data sets in the millions, that an array is going to be more performant than an array list. But once you get to that size, there are other data structures, hash sets, and so forth that are much better than either of these. Okay, so here we also can use this as a shortcut. This type inference, which we haven't really used much, allows you to skip the process. You don't to just infer what the type of the variable is using the assignment value on the right of this variable definition. So instead of having to specify array list of string, you can just use the var here, And then this will just say codes is going to be whatever the return type of this expression is. That saves you a little bit of typing. It can cause some problems if you make a mistake on the right side here and you are getting the wrong. Maybe you're expecting an integer, but for whatever reason your expression is returning a double. Then that may not show up right away when you're debugging the code. But just know this does save you some this type inference does save you a little typing. These are the common methods on an array list. You can we're typically going to use the add. This simply adds an element to the array list at the end. So if I have an array list of 10 elements and I do an add, I get an 11th element that's going to be at sub notation or at index 10. Okay, because remember it's the 10 elements start at 0, 0, 1 through 9. So if I add one, I'll get the 11th element at 10. I can also insert in the middle of an array list. I'm not really going to want to do this. So, because we just don't have a lot of need to do this in this particular class. But if I wanted to say insert an array, insert an element, at the 5th position of a 10 element list, then I could do that by using this notation. I also get, instead of using the square bracket notation to get an index, I have to use the .get method using the index. So I would say ArrayList.get index at 5, and that's going to return me whatever the value is of the 5th element. Remember that the index is 0 based, so an array list of 10 elements is going to be numbered 0 through 9. I also have size here. In the array, we use length to get the number of elements in the array. In the array list, we use size, and we are required to use the parentheses to get that. So I think hopefully you can see that array and array list really work very similarly to each other. Here's some examples of the adds. This is a string array list. Here's some examples of figuring out of using the size and the get. Here's the printout of using enhanced for loop. You also have this little shortcut. This kind of automatically generates a comma delimited list. There are more methods on the array list. The clear does exactly what you expect it to do. It deletes all the elements. Once you do that, you cannot get them back. So be careful with that. Contains is a Boolean expression. If you're searching for an object, if you want to know if a certain value is in the array list, you can use contains. Also index of. You can search through an array list and say, tell me the first index that matches this value. And you can get that is empty, remove. You can take things out of an array list as well. So you can also change the value of an array list. So if you want to add something to an array list, you use the .add. But if you want to change the value, you have to use the set notation to do that. Okay, so here's an example of replacing the value using the set method. Here we're removing an element. Notice if you remove an element from the middle of the list, then all of the index values of everything above that is reduced. So if you have an array list of 10 elements, 0 through 9, and I do codes.remove at 1, I've removed the first element. What used to be the second element is now the first element. So my array list of 10 is now an array list of 9 with indices 0 through 8. So everything above the remove point, the index value shift down 1. So just be aware of that. It's also a little problematic if you try to remove an element in the middle of a for loop. So that can cause, if you're in an enhanced for loop, it can cause some unexpected behavior. So just be aware of that if you're trying to navigate a for loop and remove elements. Here's some example of search. You can use the contains. This is a Boolean function. It returns true, false if it finds it. And then there's also the index of, works very similarly, only instead of returning a Boolean, it returns an integer value of the index or a -1 if it's not found. These are the wrapper classes that you use: integer, double, string, Boolean, etc. Here's some more examples of defining enhanced for loop. Okay, We can also have parallel array lists. So just like we have parallel arrays, we can create some more complex data structures using parallel array lists. So principles apply exactly the same as they do to an array, to a set of parallel arrays. Set of parallel array lists is the same. So if you define a person, the elements, the person number one at element 0, the name and the address are related, and we just know that because in defining our program, we have agreed to treat these as parallel lists. There's nothing in the code that forces them to stay parallel. It's just there's nothing in the language that forces them to stay parallel. It's just your implementation and management of the data. So parallel array lists apply. It's really important, though, that in order to maintain the parallel nature of the relationship, you have to make sure you do the exact same thing to every list. If I add a value to the first list, I have to add a value to the second list. I have to do it right away within the code, or else my list will get out of sync. Also, if I remove the third element from one list, I need to remove the third element from the other list. So you got to make sure that you are taking steps to keep these parallel. Okay, so we'll do an example in a subsequent video.